Hi, this is Stephen Brower from Mountain Valley Community College. This is for CSIT 256 Computer Architecture and Assembly Language, and this is the overview for Irvine Chapter 6 that we'll be looking at conditional processing. Sorry. So one of the things that was mentioned back in Irvine Chapter 4 was the idea of the status flags that are affected under different things. One is the arithmetic logic operator can perform some statements like add, and then it has an effect on the flags. And so I think one of the demos we showed where it went to 0 or went negative, and so the sign flag and the 0 flag were things that were set. And back at that time, I made the comment, well, we'll learn later how we can do something based on what those flags are. So one thing we're going to see in Chapter 6, now I'm not in neither the overview nor all the demos, I'm not going to go through every single conditional jump because there's 40-something conditional jumps. We'll be watching videos from now until August 1st. And so what I'm doing is I'm only going to cover a handful of the jumps, sort of being representative of them all. So just something to keep in mind. If you're only looking at my videos, you're not getting the information. This is really just meant to be an overview, and even the other ones are really meant to be reviewing a handful of items. The beginning of the chapter, one of the things it covers are things like the AND. Now, AND is something that actually does affect the destination. So if we do AND destination comma source, the destination is changed. And what will happen is on a bit-by-bit basis, it will do the AND. So it'll actually be taking the bits from the source and the bits in the destination, lining them up, and then ANDing them together. So, for example, if we had a statement and AL, comma, and then we have this bit stream where we have where we have these 8 bits of which there's ones in all but the 0 location. The net effect that does is it'll wipe out this bit in AL. So suppose AL contains these 8 bits, 0, 1, 1, 0, 0, 1, 1, 0. That's a little f in ASCII. If we AND that with this number, 1, 1, 0, 1, 1, 1, 1, 1, it's done on a bit basis. So 1 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1, and the AND referring to here is the AND. 1 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, 1 and 0 is 0. So the AND I'm doing here, I'm not doing adding, we're not subtracting. The AND is, when you have false and false is false, false and true is false, true and false is false, true and true is true. So it's at the bit level doing the AND. So because of that, the end result we end up with is because this bit was cleared out, we end up with 0, 1, 0, 0, 0, 1, 1, 0, which happens to be a capital F in ASCII. And that's something, by the way, is that if we're going from lowercase to uppercase or uppercase to lowercase, we're just having to deal with one bit. Anyway, so that's, there's going to be I'll jump to it later in terms of the examples, but one of the examples will show the and specifically, literally, F is one thing it's going to be looking at. Okay. Now this is ADD, and it's just mentioning that, and just jump back to this thing here. Remember, when we're doing an add, it's going to have an effect on the flags. If we're trying to detect, and I'm saying this logically, if we're trying to detect that logically there's an overflow, So let's say we have an EAX value, and let's say we're adding something from memory to EAX. And we're trying to detect by us adding that in the EAX, do we now have a number that's too big? And we can do a jump based on a flag, and depending on whether we're dealing with unsigned or signed is which jump that we should use. So if we have unsigned integers, we want to do the jump based on the carry flag. If we have signed integers, we want to do the jump based on the overflow flag. So we have to be mindful for, like in this example right here, we can know what the variable name is. We have to just remember what we have in EAX. But suppose we were doing add EAX comma EBX. We have to remember what we put in EAX. We have to remember what we put in EBX to know whether they're signed or unsigned. That's where comments are very important, so that we know what's in the registers for when we go and do some things like an add statement. So the programmer has to decide if we're detecting if there's an overflow, the programmer has to decide whether to do the jump on the carry or the jump on the overflow based on is it unsigned or is it signed. One of the later demos, which I'll recap the demos at the end, is going to focus on that. There are actually two different files that will take care of detecting if something's too big. Okay, for doing comparisons though, so if we want to compare two things, it's sort of a two-step process. So unlike in Java or C, you had if and then you had a Boolean expression, and if that evaluated true, it did a block of code. Well, in assembly, we're supposed to do a comparison and then do a conditional jump. So the CMP, which we're going to take, I'll go through this in a moment, to act on the result of the CMP requires a conditional jump. Now the CMP will compare a destination to a source. The destination is unaffected. So unlike, and let me jump back here, unlike the AND, which actually affected the destination, the CMP does not affect the destination. And just one thing to be mindful of, we can't compare memory to memory. So let's say we have two variables in memory and we want to compare the values to see how they relate. We're going to actually have to take one of those and load them onto a register, so then we can compare register to memory. Well, when the processor is carrying out a CMP, and this is the kind of bizarre thing, it will figure out every way possible in which these things relate. Meaning, it'll actually will compare, are the bits the same? So we'll actually set a flag if the bits are the same. Then it will say, okay, if these are unsigned, is this less than this? If these are unsigned, is this less than or equal to this? If these are unsigned, is this greater than this? If these are unsigned, is this greater or equal to this? If this is signed, is this less than this? So it'll figure out for both signed and unsigned every way in which they can relate, less than, greater than, and all the equals within them, and it sets all those flags. From a processor point of view, CMP is expensive. It could take 200 cycles for the CMP to be carried out, which is why there are some people, when they do big O analysis for Java, they focus only on the ifs or any of the logical operators that are taking place, because those have the biggest hit. That's the most expensive. But CMP figures out every way possible in which the destination and the source relate. Then what we have to do is a conditional jump based on, well, how we want those things to be related. So I made the comment before about the test for equality, so that if the CMP is comparing the destination and the source, one of the things we'll take a look at is we'll look at the bits to see if they're the same. So if we do a compare, which will in this case compare AL and F, and we want to now do something when it's the same, we can do, so JE, this is the conditional jump, and then go fish in this case, that's the code label that we're going to jump for. It doesn't matter whether we're dealing with signed or unsigned, doesn't matter if we're dealing with characters, it's comparing the bits. If the bits here and the bits here are the same, then when we do the JE, we'll end up going to the code label. Again, when I review the demos at the end, I'll mention the demo that has this one in it. Okay, when we're dealing with the relational operators, such as greater than equal to, less than or equal to, there are different conditional jumps based on unsigned or signed. So unsigned conditional jumps. JA, jump above. So the jump above is doing a unsigned conditional jump. Now that would mean, let me just jump back here for a second. So remember I said when the compare takes place, it's going to compare every way possible. So it's going to say, okay, if these are signed, how do they relate? Greater than, less than, greater or equal to, less than or equal to. If these are unsigned, how do they relate? Greater than or equal to, less than or equal to. So the compare is actually figuring out whether it's signed or unsigned, all the different possibilities and setting flags behind the scenes. What we're doing here is we're saying, okay, that compare that we did, let's consider it as an unsigned, and now let's jump accordingly. And so JA, jump above, JAE, jump above equal, JB, jump below, JBE, jump below equal, and there's more. The slides for Irvine have more. This is just a smattering. One of the demos we'll go to later. So here's the compare. We're looking at the car speed, and we're comparing the car speed, which we did declare as a D word, to 5, and so we're going to do an unsigned conditional jump. So JAE, jump above equal, we're going to go to brake car. Well, brake car, here we're going to subtract 5 from the speed. So when we have unsigned, we need to then use one of the unsigned conditional jumps, of which 4 are shown here. If we're dealing with signed numbers, the conditional jumps are different names. So JG is for greater, JGE is for greater or equal to, JL is for less, JLE is for less than or equal to. And so one of the demos we'll have later, we're going to be comparing EAX to, now this is a constant, which is being set to -5, so it's going to be comparing EAX to -5. Well, since we know we're dealing with signed numbers, we have to use the conditional jump. So JL less than, meaning if EAX is less than -5, we're going to go to the too small error. So the too small error here is just displaying the too small message. And again, one of the demos is going to go into this a little bit more detail. The Irvine slides have other conditional jumps. So going back to this again, sorry, let's just do the repeat. CMP, compare destination and source, will compare two things together. Destination is unaffected. It will figure out every possible way how these relate, and then we need to do a conditional jump based on what it was we compared. So if we, sorry for the chop. If we compared unsigned numbers, we need to use one of the conditional jumps. If we compared signed numbers, we need to use one of these conditional jumps. In terms of the demos, there's 5 different demo files that address the different items. Now, what you could do is, in terms of Visual Studio, I have here, this is the demo chapter 6 project that I created, which right now at this point has the starting point. And what I can do is, coming back here, I can then take the code for one of these, copy it, go into Visual Studio, paste this in, build, and then run. Again, the video will go into it further. And now if I want to run another one of the files, I can then come back and take the other file, copy the code, come into Visual Studio, paste it in, build, and then run it. So instead of having to create 5 projects, it also means, by the way, in theory, you could have one project for just demos, and for the whole semester, you can just keep copying and pasting the demo file or the contents into your demo project.